Welcome back. This is Mrs. Rubright with Advanced Geometry. Today's lesson is 6-4. Prove triangle similar by side, 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 and side angle side. Alright, so it is either triangle DEF or triangle GHJ similar to triangle ABC. Alright, so let's look. They did a nice color coding for us, which is pretty sweet, so we don't even have to figure out who goes with who. They already color coded for us. So 8 is to 6. As 16 is to 12. Let's see. 8 over 6 reduces to what? 4/3. 16 over 12, is that 4/3? 4 goes in there 4 times, 4 goes in there 3 times. How about this one? 12 over 9. 3 goes in here 4 times, 3 goes in here 3 times. Yes, so these are definitely proportional. They have a scale factor of 4 to 3, right? So this one is, all right, let's check this one out. So 8 is to 8, that's 1 to 1. 12 is to 10 is not 1 to 1, so definitely not. 16 to 16 is 1 to 1, 8 to 8 is 1 to 1, 12 to 10 is not 1 to 1. That one is not similar. Find the value of x that makes triangle ABC similar to triangle DEF. All right, well, AB goes with DE, right? Because these are listed in corresponding positions. So AB goes with DE. BC goes with EF. And then these two go together. All right, so let's try this out. So if 4 is to 12, 4 is to 12 as x minus 1 is to 18. Cross products and solve. We can reduce this. 4 goes into 4 once. 4 goes into 12 3 times. 1 times 18 is 18. 3 times x minus 1. 3x minus 3 equals 18. 18 plus 3, 21. 3x is 21, so x is 7 divided by 3 on both sides. We can check that out over here. 7 plus 1 is 8. 8 times 3 is 24. Is 8 times 3 24? It is. 4 times 3 is 12. 8 times 3 is 24. Over here, the 6. 6 times 3 is 18. It checks out. We know we didn't mess anything up. Our x value is 7. And these triangles are similar by the side, side, side similarity theorem. Because all 3 sides are proportional, they are similar by side, side, side. Which of the 3 triangles are similar? Write a similarity statement. All right, so let's see. We have small, medium, large, right? Small, medium, large. Where's small? Small, medium, large. Small, medium, large. So I'm going to compare my smalls. Compare my mediums, and compare my larges. You guys see how I order them from least to greatest so I know what goes with what? Isn't that the easiest way to know what you're supposed to set your proportions up as? It's just kind of a little trick. So 20 is to 24, right? Small is to small, as medium is to medium. 24 is to 30, as large is to large. 26 is to 33. Let's see. So, over here, 4 goes in here 5 times. 4 goes in here 6 times. What? 6 goes in here how many times? 4, and 6 goes in here. Are these the same? How about here? Well, we already know from here and here, can these be proportional? No, so these two are not proportional, right? Let's try these two. So if we have 20 is to 30 as 24 is to 36 as 26 is to 39. Let's see. 2/3. 12 goes in here twice. 12 goes in here 3 times. All right, 13. Is that 39? Yeah. 13 goes in here twice. 13 times 3. 13, 26, 36, 39. 3, right? 2/3, 2/3, 2/3. So these two are positively similar. Right? So we tried these two, no. We tried these two, yes. The only other two we could try is these two, but if these two are similar, these two won't be, right? 24 is to 30, as they're not going to be the same proportion. Let's see. Make sense? The shortest side of a triangle similar to triangle RST is 12 units long. So similar to this triangle, the shortest side is 12. Well, what's the shortest here? This is the shortest, so put it in the same position. 12. Looks like an ice cream cone. Find the other side lengths. Okay. Well, 12 times 2 is 24, right? Or 24 divided by 2 is 12. So I can do by proportion, or I can just look and see. 24 divided by 2 is 12. 30 divided by 2 is 15. And 33 divided by 2 is 33 over 2. Right? You got your 15 and your 16 and a half. So you can do the proportions, or honestly, just drawing this, that's enough work too. And to increase your work a little bit, you could just go like this. Divided by 2, or times 1/2. Right? You are building a lean-to shelter, starting from a tree branch as shown. Can you construct the right end so that it is similar to the left end using the angle measure and lengths shown? All right, so can you construct the right end, so this end, that is similar to the left end? All right, what do we have? We have an angle that's the same, right? Same angle. Are our sides proportional? Let's see. Is 6 is to 9 as 10 is to 15? Is that true? Let's see. This reduces to 3 goes in there twice, 3 goes in there 3 times. 5 goes in here twice, 5 goes in here 3 times. 2/3, 2/3. Same ratio. Therefore, they're proportional by side, angle, side. They are proportional. They are similar by side, angle, side. See how I did that? Tell what method you would use to show that the triangles are similar. All right, so we have right here, vertical angles are congruent, right? Now let's see if their stuff is proportional. So which one's the smaller amount? So 9 is smaller. Out of these two, which one's smaller? 15, right? So let's see. 9 is to 15 as 18 is to 30. Let's check this out. 9 times 2 is 18. 15 times 2 is 30. This should totally work, right? 3 goes in here 3 times. 3 goes in here 5 times. 6 goes in here 3 times. 6 goes in here 5 times. 3/5, 3/5. They totally are proportional by side, angle, side. Make sense? Explain how to show that the indicated triangles are similar. Explain how to show that the indicated triangles are similar. All right, so do you guys see how they have an angle in common? Let's see if they have side, angle, side. So 24 is to 18, right? Smaller amount, larger amount, larger amount. All right, so let's see. 6 goes in here 4 times. 6 goes in here 3 times. 7 goes in here 4 times. 7 goes in here 3 times. 4/3, 4/3. Are they proportional? Yes, by side, angle, side. Explain how to show that the indicated triangles are similar. 90 degrees, 90 degrees, right? We have an angle. All right, so now, side, angle, side. Let's see if we can do this. So, what do we got? Smallest on this one is the smallest on this one. So the 12, smallest to smallest. Middle to middle. Largest to largest. All right, 3 goes in here 4 times, 3 goes in here 3 times, 4 goes in here 4 times, 4 goes in here 3 times, 5 goes in here 4 times, 5 goes in here 3 times, 4/3, 4/3, 4/3. They are proportional by a scale of 4/3, right? You can say side, 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 or you can say side, angle, side. It's really just personal preference. Both of them do solve it. And that is everything on today's lesson, which is 6.4, prove triangle similar by side, 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 and side, angle, side. I hope you guys enjoyed this lesson. Please like and subscribe and have a wonderful day.